Oh, what a glorious thing to be, a healthy, grown-up, busy bee, whiling away the passing hours.
Welcome back to the workshop. In this part 3 of the mini-series, I shall be covering the mounting of the embryonic rotary table onto the 4-inch rotary table, which I shall use for laying out the slots, the holes in the peripheral rim, and probably some engraving lines as well. But we'll see how that progresses. Over to the workshop now and see how it's done. This is the machined up rotary table with the bearing recess in the bottom side. What I've decided to do is use the smaller of my 2 rotary tables. This is the 100mm one. I've cut a 100mm by 100mm square of aluminium, 10mm thick, drilled and reamed a 10mm hole in the middle. I shall then be using the PCD function again on the mill to drill 4 mounting holes so that I can mount the plate on the rotary table. This will be centered up on the mill. The plate will then be attached to the table. The plate will then be centered on the mill. This will then be mounted on a boss which locates in the bearing system, and it'll be clamped to the hole, to the plate, via a bolt which will come through from the underside. That's the plan. Unfortunately, I found that I hadn't got any T-nuts, so I had to run up for T-nuts, which has rather delayed things, and hopefully I'll be able to get on with that a little later on. I've brought the rotary table over to the mill just to demonstrate a bit of a conundrum I have with it. For reasons best known to the manufacturer of the table, when the graduations are set at 0, the slots are rotated by, as best I can measure, 28.2 degrees. I don't know why, but there we are, we're stuck with it. So what I propose to do is to drill the mounting holes from, if this is the 0 position, 28.2 degrees in that direction, and then at 90 degrees using the pitch circle diameter function on the DRO. That'll be at a diameter of 70mm, and allow me to mount the plate such that the orientation is as near parallel to these and perpendicular to these slots as possible. That will mean that the edge, or this edge of the plate, is nearest damn it parallel to the back face of the vise. And once the table has been mounted on the vise, on the rotary table I should say, and the graduations set at 0, I can mill the slots using the X and Y axes as normal, and I shall also drill through the outer face at 40 degrees off from here and 40 degrees off from here, tap the table and then secure the rotary table to the base plate. I'm not describing this very well, but as we go along I think you'll see what I mean. Hopefully that will prevent rotation of any rotation of the plate as it is turned round for drilling the other holes in the peripheral flange and also for the engravings. And I'm just about to start centering the plate under the spindle using the coaxial centering device. But before I do that, a quick confession. In order to secure the table to this plate, I've cut the end off the arbor which I used for milling the table to size, and the intention was to have a bore, a spigot rather, on it to match this 10mm reamed bore, and I turned it down, and then due to a bit of stupid upcockery with my newly made Hemingway tailstock die holder, I pushed the die holder clutch mechanism the wrong way, and instead of just threading the end, I managed to thread the carefully turned 10mm diameter. Luckily, the crests remain at exactly 10mm, so that was a bit of a bonus. So I've turned the end down, and fortuitously an 8mm thread here fits with a hole nut inside the centre of the rotary table, so actually it worked out okay in the end, but I'm annoyed with myself for messing up that journal. However, back to the basics, and what I'm doing now is, well, I'll have to turn the mill on. Unfortunately, it's got a continuously running fan, so that will mess up some of the sound, I guess. Here goes the DRO. I've roughly adjusted the probe by eye to the centre of the hole. I'm now going to zero the axes, X and Y. I'm not sure I do Z at the same time, just to keep it neat. If I now set the spindle turning at a low speed, you will see the needle on the indicator varying quite widely. Now, taking one axis at a time, and first off I'm going to do the x-axis and turn it one way, and you'll see the deflection getting greater. So I turn it in the opposite direction, the deflection goes down to a minimum and then starts to increase. So back off a bit and over to the Y, turn it in one direction, deflection increases, so go back the other way until the deflection is at a minimum, and we know we're getting close. So back to the X, reduce that even further, that's about it, and the Y again, that's getting bigger. Y again, X again. Y. We're getting close now. X. Y. Oh, we're within a gnat's kneecap now. And that's just getting some surface roughness on the hole, despite it being reamed. It's got a little bit jiggered up with the thread I cut accidentally, so I reckon that's as good as I'm going to get it. Lock the x-axis, lock the y-axis, stop the machine. That is now centred on the hole, and for reasons which I will explain in just a minute, I'll be drilling some 4 holes for the T-slot connection, and I've also decided to drill some of the peripheral holes through to the plate once it's mounted on here, tap them and secure it to prevent the table moving as I progress with the job. I propose using these button head screws to secure the plate to the rotary table. What I shall do is drill the 4 holes and then use a end mill to recess the head into the plate by 3.5 millimeters. I'll do the first one and then do the rest off camera. I've already set the pitch circle diameter parameters into the DRO, so first off we'll move the x-axis to 0 position on the DRO. I don't think you'll be able to see it, you'll just have to take it from me that we've got there. And we'll and then we'll creep up on 0, lock the axis, go to the Y, and inevitably turn the handle the wrong way. 0 Y axis, and lock the table. I'm drilling straight through with a 6 millimeter drill. I think it's stiff enough not to wander, particularly in aluminium, and it's a brand new drill. I shan't bother to spot drill it. Hang on to your hats, here comes the spindle. Yep, that's drilling okay. I'm just going to get some WD-40 and give it a bit of lubrication. Off we go again. Hole number 1. I've now got a 10mm end mill in the spindle chuck, and I'm going to run the spindle at a reasonably slow speed and just bring it up to touch it off. Here we go. 0 the third axis. No, I can't do that in CD mode, so I'll use the quill vernier gauge digital vernier and bring it down 3.5mm. Again with a squirt of WD-40 juice. There we go. sufficient hands, unfortunately. There we go. Get rid of all the muck. The head of this button bolt is slightly over 10mm, I suspect, and yeah, won't fit in there. I'll just have to turn the edge off, but rest of it fits. Okay, right, I'll do the other 3 off camera and bring you back and you can see the finished article. So there we are, all finished, in as much as the 4 holes have now been drilled, counterbored, and it's ready to take off, put on the rotary table, and just hope that I've got the orientation of the holes in the right place. Time will tell. So that's the end of part 3. In the next part I'll be mounting the base on the rotary table, a whole lot in the mill, and try to centre it up. That should be interesting. Anyway, if you have been, thanks for watching, and I'll catch you next time.